Alright, so in this lecture, we'll be discussing about the most interesting topic called rotation, about multiple axes, more than one axis of rotation. Fine. For example, suppose that this is the hinge over here, let's say, fine, and this is nothing but the disk over here, fine, and over here it's rotating, rotating about which axis? About this one, fine. In this way, let us say, fine. At the same time, it is not only rotating about this axis, it is also rotating about the other axis over here. You can imagine how the situation is. Let's call this one as the other axis. In this way, it is fine. Omega 2 it is. So it's rolling. It goes this way. Fine. And what is this object? This object over here, it has a moment of inertia of let's say it's a ring. Mass is m, and the radius is r, and this distance over here is nothing but equal to, let's say, L. It is fine. So we want to find out what the kinetic energy. Right? Now it's easiest if you were to write the kinetic energy as equal to the sum of the two rotational kinetic energies. Instead of trying to write it as kinetic energy of translation plus the kinetic energy of rotation. Why? Because these are two axes, right? Axis of rotation is this way. The one is the hinge, one is its own passing through its center of mass. So we'll write it this way. The Ke of rotation about the axis called the axis number one. Which one is the axis number one? This one. Right? And which is the axis called the axis number two? This one, your axis number two. So Ke of rotation about one plus the Ke of rotation about the other axis called axis number two. This is a total kinetic energy. Very simple concept. It is not at all difficult. Can be cracked easily without effort, effortlessly. So what is the moment of inertia of the object about this axis? And what is the moment of inertia of this object about this axis? We'll do half I omega square and half I omega square about these two axes. And that's all. That's the answer. So we get this as equal to half I1 omega 1 square plus half I2 omega 2 square. The moment of inertia about the axis number 2 is nothing but, for a ring, is given as equal to simply mr square. For axis passing through the hinge, you'll have to use the parallel axis theorem, because here you have the axis through the center of mass. And this is nothing but equal to how much? About the diameter plus mass multiplied by the square of the distance, which is between the two axes, ml square, half mr square plus ml square. This is the value of I1. And substituting, we get the answer. Fine. Yeah, this is a very, very short principle. I hope this is clear. No doubts are there for this one. Thank you for attending, gentlemen and gentlewomen. Yes, thank you.